join. We will invite now Shri Aakash Gupta, ThinkEvolve consultancy from Navi Mumbai. Mr. Gupta, are you there?
Hello, sir.
Yeah.
Should I start sharing my screen?
Yes, please.
So VanNetra is the platform that we have brought in. It's a wildlife monitoring platform which can ingest data from multiple sources and provide typical use cases for the users where you're looking for human-animal conflict areas, looking for poachers, identifying poachers in those areas, or identifying people who have come into non-sanctioned areas. So this VanNetra classifies and identifies images not only from camera traps but also from drone images, from any kind of real-time based cameras. We can identify tigers. Individual tigers can be identified. Individual species of animals can be identified, and we can use that to map it with data coming from M-stripes, data coming ingested from other locations like satellite data and other images. So let me just show a sample example. Is processed video which we see out there is where images are coming from a real-time camera kept on the field, and we're using that to identify individual elements over there. We also can look at and estimate their length and height, estimate individuals out there. This system can be mapped to allow individuals coming from different cameras, coming from say infrared, coming from thermal imagery, drone imagery. Those can be ingested into it. It's a typical dashboard that you see out here where individual tigers can be mapped. These can be done for elephants, can be mapped out there. We can see their movement patterns across the entire geography of the forest. This is for identification. We are looking for provides an analytical layer on top of it, on top of any kind of systems which are being built in. We take data also ingest from M-stripes and creates a layer on top of it. If you are identified any kind of humans, they are identified from the images. We classified that into staff versus non-staff, authorized and non-authorized people. Face recognition is taken place, and those images are sent via email or WhatsApp notification to people on the ground. We can identify people who can be these things can be sent so that they can take immediate action. Data can be streamed either from satellite, either from edge or streaming cameras, or from any kind of a UAV surveillance which is set up. It also provides, on top of it, it provides a document store which can help you search for individuals, tigers as well, providing a very good analytical layer on top of all the data which is there with the forest department. We also provide animal behavior. What we see out here is animals being targeted with getting temperature, humidity and wind information. Typical cameras are detector, the bridge and the siren, which works on that. We work on, it's a passive IR sensor is there with the temperatures out there, minus 40 to plus 60 degrees centigrade it can take. It can be run in any kind of region which is available. And the batteries are good enough for 400 days. So the battery that is set up out there will be running for 400 days continuously, will still be connecting with the master control. This is a top view. It's a PIR detection zones that we have, which provides a total view of it as well as a distance to which we can do the detection and classification of that. Ingestion of SAR imagery, satellite imagery, I think we can take in. We can look at carbon stock disturbance, which is very useful. If there is a fire season taking place, we can identify it earlier with our analytical capabilities. We can identify those regions of it. We can look at water bodies which are there, identify those given the satellite imagery. And irradiance data from solar irradiance is also captured and populated in the information. So that is it. Thank you. If there are any questions, I'm happy to answer.
So you have this intrusion system as well, right?
Yes.
Meant for intrusion. So we have a classic issue in Odisha. We have a high elephant conflict in certain districts. So we want to have a system, in a village, for example, we want to geofence the entire village, maybe the sensors. But then it should not also give a false alarm. It should be only taking the height of the elephant. Maybe a big adult elephant having 8 or 9 feet height, that sort of an elephant. We geofence it at around 8 feet or so. And then that sensor should be able to capture that elephant, detects intrusion and then senses the alert. It can be a combination of your cameras and sensors and other things. So do you have any experience of this kind of?
With elephants we have not worked. We have worked with tigers and leopards. But what the system does is it captures and with 98% accuracy it identifies the species of the animal. The image that comes out from it is also used to identify the height and length of the animal. So if that is done, which we can, so that mapping can be done to raise an alert only if an elephant of a certain size is entering the area or the reference area.
I'm not talking about camera input. I'm talking about the sensor input. Invisible sensor radiation, being a beam of say laser or whatever. I don't know what sensor you will use, but then that is getting intercepted by an elephant, and then the system capturing it and giving the alarm. Because sometimes the elephant get into the villages and damage the houses and kill the people.
Understood.
We have such sort of situation. So we want to have say around 2 kilometer or one village, from the village center to around 500 to 1 kilometer radius. We want to have the entire area geofenced. It's like a virtual fence. And including that at a height of 8 feet, we want to get an alarm.
Correct.
So that
could be possible. Yeah.
Then it should give the siren alarm or whatever.
Just to include here is that this question would be for all the participants. So for all the participants who are yet to speak, this question that has been posed by Mr. Lade has to be specifically answered, because this is one of our major areas where our shoe pinches. We have a lot of elephant deaths and human deaths, and this is a very critical problem in this part of the country. So all the participants henceforth should address this particular issue. And to that, my another question is that you already said that the length and the height of the animals can be detected. Now for tigers it's perfectly simple, because there is a pattern recognition software and extract data you are pulling in, so you're kind of identifying the tigers. But our problem is that tigers are limited to in some parts of the state only. The major problem here is basically elephants.
Yes.
We have started a task, something called as tusker profiling, where we get to know that how many adult tuskers or sub-adult tuskers are roaming this thing, and from that we are wanting to know who are the truant or the problematic tuskers who are more keen on house raiding, or basically they have killed people in the past, and there is a lot more chances that they can do that in the future. So to identify them and to aid us where the human eye and the human presence always cannot be ensured, how does your technology or can your technology actually ensure that for us?
So we can add that. So what we use is kind of identifier for individual elephants based upon their structures, the body structure, their elephant structure. We build out key points, a key point strategy where we identify landmarks on those images to identify individual animals out there. So that can be done. It is a process for us to start it, and we can implement that in our solution.
Can we just go back to your presentation where you showed that 3 components, detector, bridge and siren? I just want to hear that over again.
Is my screen visible?
I said no. Yeah. Yes. what are these and what will they do?
So the first one is a detector, which is a PIR sensor, along with a camera which is set up out there, which is a 2K pixel wise camera. The bridge forms a kind where it disconnects to the control room. So you have a bigger control room, and these in a hub and spoke model. It is actually a kind of a hub, spoke, and a mesh kind of an environment where individual detectors can form a mesh, and the bridge forms a kind of a connector between that and the control room. The siren is what we consider as set up out there to ensure that any kind of animals which are coming up in regions where there is a human-animal conflict, that it sets up an alarm for that at 108 decibel, which is enough to alert any villages around those areas.
So what would be the ratio of the detector to bridge if it is installed?
So 8:1 is typically one bridge can take about 8 detectors. I'm sorry, is there a question being asked, because I can't hear it?
You can't question?
I didn't hear the question.
Sumit, could you please repeat it?
I'm sorry, Sumit sir, your voice is not coming through.
Okay. I'll ask the question for you. I think Sumit, probably you're asking that if there's a thick canopy, be it bamboo or any other thick, that actually intervenes in the clear side.
I'm sorry, I didn't understand. I didn't get. I'm not.
The question of vehicle internal is basically that where you do not have a very clear line of sight, and you have thick canopy, thickets here and there, bamboo bushes popping up, and how does the net connectivity get affected, and how is this bridge connecting to the detectors and transmitting the information back to the places where the siren should probably work gets affected?
So the technology on which this proprietary technology on this which it works goes through thick foliage also. So that connectivity is not a problem for us. So even it works in thick foliage, it's being used by militaries across the world.
So we basically can have a... What is the technology like, Mr. Gupta?
So I can't disclose it in this forum. It's basically based on radio frequencies. But that's a high level I can disclose. It's a patented technology.
So there was a question on, or rather a use case on identifying some of those elephants as truants. So what would be the method that you deploy to not only identify those elephant herds, but also accurately identify this particular animal as a truant, so that next time on maybe we could devise a system or a process that the alarm goes off in those particular villages where the truant is going, or maybe predict his pathway so that we can maybe put in additional measures to protect the villages. Yeah.
So this I'll have to get my data science team on this, but typically these systems work in identifying individuals who are truant. There's also a behavior aspects of it, but identifying individuals is possible. We can take their images and get them identified individually and map them to the individuals who have been truant.
Is that if we want to, with an intention to reduce human-elephant conflict in many of the vulnerable areas, and when the machine is installed for a period of time, can this machine learning predict on the behavior and its truancy, seeing that what is the frequency rate in which it comes out of the forest, in which areas it comes out, so that it can have a prediction to us, giving us a model that yes, there are chances that if it has not come out in a particular area for about 15 days, the chances are 100% that it will come out. That kind of a prediction model where we can sound alarms, that we can prevent these control incidents to happen in future. Can we develop a prediction model based on its past machine learning experiences? Is it possible?
Yeah, so based upon their observed patterns, there are research which is ongoing which identifies elephants which can be trawned and gives a probability level of their occurrences.
Is it possible or has it been tested?
It's in research. It's a research area.
Any questions further, or we then go to the next one? Yeah, okay.
Thank you,
Thank
sir.
you, Mr. We then go to Mr. Prabhakar Behra, Total Technology Systems.